making a heap of these little brass washers. So it's easy to deburr the front side and the two outside edges with the file, but when it comes to, a piece of sunlight's coming through there, when it comes to deburring this inside edge, it becomes a bit of a mission. So we'll show you how I would tackle that. Very easy way. Well, g'day, Max here again, welcome back to the shop. So this will be the last in the series of our short run repetition videos. So we've just got our fixture plate mounted up in the mill. We're just about to drill and tap all of the mounting holes in the plate. So we'll just give you a quick overview of that, as it's been done several times before by other people. And then we'll use the plate to carry out the machining processes on these parts here. So this hole has to be bored for a press fit for the bearing, so there's a few of those to do, and then just a couple of small fixture to machine on those parts there, which will all be done on that fixture plate. And then we'll move on back over to the lathe, and we'll get into our new chuck that we brought for the lathe, and how we carry out a simple way for repetition machining in the lathe with soft jaws. Now, using the soft jaws, it's only suitable for certain types and design of parts, but it does cover a wide range, so that'll be later in the video. So let's get over to the mill. That's all our holes tapped, so they come out very well. So that's a good reason too why I don't like to buy cheap crap taps. So that's this one here, the M10 gun point tap. It still has not got a mark on it. It's like it's never been used. So I don't know how many cycles are rated for this tap, but I'd say without a guess there's 99 holes, so you could probably do 1,000 holes straight up with this tap without it batting an eyelid. Now, that's the difference between a good quality tap and some cheap rubbish. So what I'll do now, we'll move on, we'll get this deburred on the underside, and we'll get it mounted up in the Kurt vise, and we'll put it to use. Okay, let's get our vise mounted up. A couple of T-slot bolts. So what I'll do is I'll just put a very light nit down on that one and a slightly heavier nit down on that one. So I've got our metric indicator on at the moment, so that will do. should be right there. So we'll start off down this end here, which is the end we have the tighter of the two nuts. We'll zero our indicator. And as we travel along to the other end, we'll start tapping the vise to get a bit of alignment happening. So I'll just stop there. We can see the needle coming around, so we're getting higher up there. So we'll just tap it back round. Back the other way. Okay, that's it. She's done. Now, because it's a metric indicator, we're under 1 division. So we're less than 0.01 millimeters, which is 4/10 of a thou. So we're under half a thou, so that's fine. That's how easy it is. Just keep one side lightly nipped, the other side just a little bit more torque on the nut, and as you're travelling along you can read your indicator whether it's starting to read high or low, and just tap your vise either side accordingly. And I will get a Noga one day, retire this old one. He's older than me. Well, okay, the first job for our fixture plate. So we've got a heap of these plates. Now, we've had this whole water jet cut, as with the rest of the bracket. And this eye here, this hole here, has to be bored out for a press fit for this bearing. So rather than just ploughing blindly and start trying to get a size off our hole and hope we don't bozo anything up, because it could take a couple of cuts. You go through a couple of brackets to get your boring bar to cut on size, so you're getting repeatability. What my method is, and I'm sure a lot of other people do the same thing. So I've got a similar material. So my first hole I use to get the boring bar on size, and then I'll push the boring bar through 2 more holes to make sure it's repeating correctly. Now, I did pre-drill these holes to 15mm, as is the size of the hole in the part. These have been water jet cut to 15mm. So that gives us the best possible opportunity then to run all these parts through without a boring head adjustment after the first one, and should get good repeatable results with it. So we'll get set up and get our brackets mounted in our fixture plate and start boring. Okay, so we have a very basic setup here, which is the name of the game. So we have a 10mm piece of thread screwed into our fixture plate, with the end of it just machined down so it's a neat fit over the hole there. So we're going to locate off that hole. This just pushes up against a hard stop I have behind this clamp. I have a piece of scrap to protect the part. So I'll just push up against the hard stop. And nip it down. So on our clamp we have a spring underneath it, so when we slacken off it lifts the clamp, and we have this other bolt, alignment bolt, behind the clamp, and that stops the clamp swiveling around and going out of position when we slacken the clamp off. So all we do then is just run our bar through the hole and we should all be good. So that's our fixed stop we have behind. It's just another one of these clamps, strap clamps, and the part just pushes up against it. check our size. There we have it, smack on 16mm. So this one's good to go, and of course our bearing, our little bush, that'll be set up for a press fit in there. So I'll run the rest of these through. And of course the size check on our last one. Spot on. Okay, this is our next operation on the other part. Still in the using the fixture plate. So we get this around the right way. So we have to take a portion off this area here, approximately 1mm deep, and back just as far as that pencil line. So we've got basically the same setup, the same clamp, spring, extra bolt, backstop, and if we come around here and just see it there, that's our locating dowel, which picks up on this hole here, same as the previous part. So I'll crank the mill up and shave the little bit off the end there. Okay, so we've got our little washers here. We have to deburr just one edge on them. So my thoughts on this, it's the easiest way I could think of. We use our new chuck. So we'll have to bore a little recess in the jaws. So I'll put a little dowel pin up inside the jaws. Just something to tighten down onto. And we can go ahead and machine a little recess. It's a bit noisy because I've got the mill running in the background. I'm just drilling some holes in that fixture plate. Well, I'm not, the milling machine is. So I'll just go and reset it and come back. Okay, so we're just going to do a small recess with the lathe and gear. I'll move the camera so you can see. Okay. We're just eyeballing this. We can go a bit more, a fair bit more. A little bit more. Yep, that should be okay. Just deburr that. Okay, we'll take out our spacer, our pin. So that's created a little step in the jaw for our washers to sit in. Okay, drop that one. So I'll go searching for it. That's all we have to do. And as you can see, it only has to be just enough to grip the part. Okay, so what we're doing here, we're just boring this piece of scrap out to 1.612 to 1.613 diameter, and what we do then is we note our position on our cross slide dial. So what we're going to do is bore our set of soft jaws out, and because we can't measure between 3 points in the chuck jaws, that's why we're just boring a scrap piece to establish our correct diameter with the tool. So without upsetting our dial readings, we just wind the tool back and we fit the soft jaws. So it's just basically a method to set your diameter you're going to bore your jaws at using the piece of scrap. It's a quick and easy method, and it's accurate. We'll swap our jaws over. Find number one. Number one goes there. Number two. And number three. So all I've got to find now, I haven't had time to drill these jaws for a setting ring to go over to hold them when we bore them. So I'm just going to put a scrap piece of material in the back of the jaws. So I'll just go and find something. Okay, well I found this piece of scrap. The main thing is it's smaller than the diameter we want to hold, because we have this part and we want to machine this hexagon feature. We want to machine it round, and we're going to be gripping it on this small feature here. So that's why we're going to use the soft jaws. It gives us a positive location to grip on this shoulder. So what we do is have a piece of offcut. So yeah, we make sure it's a fair bit smaller than the diameter we want to bore. So when we put it in the chuck, we can eyeball our part, the diameter that we have to be, to making sure we're getting full jaw coverage on the part. So that's determined by the diameter of the scrap that we hold. If the scrap that we hold is too big, when we put our boring bar and in and bore out the jaws, we're not going to get a very wide jaw coverage. So we've got our boring bar set, so we'll run a cut through. So there's a fair bit to come out. There's a couple of 100 thou to come out, and we know our finished position because we've registered on the dial already. So okay, we're just going to measure now how far we're bored in. Just 2 millimeters. We've got a shoulder to hang on to of 6 millimeters, so we want to be bored in about 4 millimeters, so I'll go a bit more. There we have 4mm. Now, if you overbore at this stage, it means your part's going to sit in below the level of the face of the jaw, which is not what you want. So if that was the case, you'd have to face off just a little bit on the front of the jaw to allow your tool enough clearance to go in and traverse your part. So our depth is fine, so we'll take a final cut through now of 20 thou. And also on that final cut, once I did bring the tool in a bit, so we did undercut the very back of it, so our part can sit in on a square corner. So that should be pretty well sized for that, which it is. So take our clamping piece out. And it's a matter of just put our part in. And that will hold that dead true. Any run out we get is run out on the hexagon, as these have been machined in 2 operations on a CNC, as this diameter is not concentric with the hexagon that's on there. So I have not touched this diameter, all I've done is polish the black off it. So that's how I found out, yeah, these were done in 2 operations, as there is run out between the 2 areas. So I'll set a tool up now, and then we can carry out the operations that we have to do on this part here.